within your application designs. So now that we have a very clear picture on what a design pattern is, let's move on to the next topic of our discussion, wherein we will try and look at what is dependency inversion and what is inversion of control mean over here. We know that when we do designing, there are multiple software design principles. These software design principles are guidelines that tell us what is right and what is wrong for good software design. To dependency inversion principle, there are multiple common design principles that are available today. And these principles, the software design principles that we are talking about, they were proposed by a person called Sir Robert Martin in the year 1992 and was coined the term called SOLID, which is SOLID, where each letter is a principle. For instance, SOLID, the first letter S stands for single repository or the single responsibility principle. Then you have O, which is open closed principle, which primarily says that when you are creating class designs, your class designs should be open for extension but closed for modifications. The L stands for Liskov substitution principle. The I stands for interface segregation principle, and the last digit, the last alphabet, which is D, stands for nothing but the dependency inversion principle. So these are some very popular design principles which, if we adopt it within our application development environments, we would be able to get our designs correct, and at the same time we will be able to create designs which are maintainable in the future. So what is the dependency inversion principle all about? If you look at dependency inversion principle, according to this principle, while you are designing your class modules, if there are any high-level class modules, these high-level class modules should not depend on the low-level modules. Instead, they need to depend only on abstract versions of the low-level module. Abstractions should not depend on implementations. Rather, the implementations should depend on abstraction. So these are two very key points related to the dependency inversion principle. Now let's try and understand this with an example. So while we are saying that the dependency inversion principle tries to highlight the way we should be creating our high-level class modules and our low-level class modules, we need to see how do we design the high-level class modules and how do we go ahead and design low-level class modules. Which one could be considered as a high-level class module and what is it that goes as a low-level class module. Now, to be able to explain this particular points with an example, let me switch over to a specific image. Now, in this particular diagram, we are having a copy program module, which means there is a class that I have created which is responsible to perform the copy activity. Now, this particular copy program is expected to read some information from an input media and copy that information onto an output media. When this particular copy program module works, it will go ahead, for instance, and read information from keyboard reader classes and printer writer classes. Assuming my application does not use the dependency inversion principle, my copy program module would directly create instances of the keyboard reader and the print writer classes, and then go ahead and call maybe the copy functionality of the keyboard reader and the print writer classes. As far as our current scope of the application is concerned, probably this design is meeting the current set of requirements. However, if over a period of time there are certain enhancements required to your application and your application is expected to extend itself such that in addition to reading from a keyboard reader, the application should also be capable of reading from another input device which is like a file reader. At the same time, it should also be able to write information not just on a print writer object, but it should also be able to copy that information on a file writer object. Now, earlier, because we had only two particular classes, which is a keyboard reader and a print writer classes, which were directly interacting with the copy module that we have, it was well enough. But now that we have to add two more new classes, it would involve us to go ahead and rewrite the complete copy program module all over again. So if my copy program module was having instructions in the copy program module which said I have to create an instance of keyboard reader and I have to create an instance of print writer, now because there is a provision, I should also be allowed to create instances of the file reader and the file writer classes. Now, to be able to incorporate these new set of requirements, you would land up changing your entire copy program module. So the entire copy class declarations that you have, you would need to go ahead and rewrite the complete copy class module such that in addition to creating instances of the keyboard reader and the print writer classes, it should also be allowed to create instances of file reader or file writer, which is actually violating the principles of software design. We had a principle which said open closed principle. In this kind of a scenario, you have a design which is open for extension but at the same time not closed for modification. The design needs to be completely modified to be able to incorporate all your new requirements, which is a very, very dangerous sign if you have multiple change requests coming in from the customer. Go ahead and change request that comes in. Now, in this high-level class module, which is directly creating instances of the low-level module. Because it is directly creating the instances of the low-level module, there is tight coupling that gets introduced between the high-level modules and the low-level class modules. Again, a violation to our thumb rule for good designing, which said you should have designs which have loose coupling and high cohesivity. But our current design is not supporting loose coupling. To be able to overcome these multiple issues which are there in our previous implementation, we move on to the second implementation, which is using the dependency inversion principle. Now, according to the dependency inversion principle, the high-level module should not depend on the low-level modules directly. So, in the second diagram that is there, you can see the high-level module, which is your copy program module, is not dependent on the low-level module classes directly. Instead, you have a layer of abstraction that has got introduced. So you have an interface created for the reader. You have an interface that gets created for the writer. And from these interfaces, the reader interface and the reader-writer interface, I will go ahead and implement different reader objects classes and different writer object classes. So if you notice, your copy program module is a high-level module. It is not interacting with the low-level concrete classes directly. Instead, the high-level module is interacting with the abstracted version of the low-level modules, right? And now the abstracted versions in turn are connecting to the concrete classes and getting it implemented. So if you had created a design, and I would request you to just focus on the circles which are on the black here. So you would see multiple things wherein, just try to highlight it for you once. This happens to be your copy module, right? Then you have your interfaces. So these are your interfaces, and these all are your concrete classes. The high-level module is depending on the low-level abstractions and not on the concrete classes. To start with, just close it without saving. Just give it a minute for it to get refreshed. Yeah. So now if you see, my initial design said the copy program module was using the instances of keyboard reader and file reader and maybe the file writer and the print writer. Over a period of time, if requirements change and now they say, okay, you should also extend the application to read from a scanner and at the same time copy that information onto a Xerox writer class. What I have to do, I need not go ahead and modify my complete design, neither do I need to rewrite my entire copy program module. I will just need to create two additional concrete classes, the scanner class which implements the reader interface, the Xerox writer class which would implement the writer interface, and your copy module remains unchanged. With this introduction, you are ensuring that there is loose coupling that exists between your high-level modules and your low-level modules. So going back to our discussion of dependency inversion principle, where we said when you are designing modules, the high-level modules will not depend on the low-level modules. Instead, they will depend only on the abstract versions of the low-level modules. and abstractions will not depend on implementations. Rather, the implementations would depend on abstractions. So, with this particular guideline, we will go ahead and start seeing how can we adopt the DIP principle in all our software design creations. So while the principle, which is the dependency inversion principle, helps you in laying down a guideline we should follow during designing of modules, there is a pattern that we need to adopt, because the pattern outlines the approach that has to be followed for using the dependency inversion principle. Now, what we have, the IoC, which is the inversion of control, is nothing but a design pattern that gives us different ways of implementing the dependency inversion principle. So let's see how do we go ahead and use the IoC pattern in our applications. So we had talked about a file reader class example where we had a copy module and we had to copy from a reader class onto a writer class. We also saw the design of how can a low-level module, how can a high-level module get directly be dependent on a low-level, what is the impact it creates, and if I create or introduce a layer of abstraction, what is the advantage of using that. I'll try to give you another example with an employee and an address combination where I have an employee class and I have an address class, and there is a relationship that exists between these two classes, which is a composition relationship. So let me just switch back to another diagram. And I'm assuming the diagram is now visible to all of you, wherein take a situation where I have an employee class and an address class. The employee class has got one attribute which is nothing but an object of the address class, right? So if you notice over here in this particular diagram which is displayed, your employee class has got an address, and in addition to having address, it also has employee ID and the employee name. And then I have my address class which is giving door number, street number and the city. Now in this kind of a class design, if you see, the employee is expected to create an instance of the address class. Your employee is a high level class, the address is what is a low level class. Employee and address have a composition relationship, and as part of the employee constructor method, you will create an instance of the address class. So the address object is created by the employee constructor, introducing tight coupling between employee and the address class that might get arised. What are these problems? The first problem, there is a dependency which has been introduced. The address class cannot change itself without the employee class not getting impacted. So any change in the address class will go ahead and impact your employee class as well. If your address object creation fails, the employee object will also not be created. So if the address object has not been created or there is a problem, then you will find issues in having the employee object also getting created. And the last and the very important issue that would have to be addressed because of such a class design is, what if tomorrow I want to add a new address type? Currently my address class is having door number, street number and city. Now I also want to add another attribute in the employee class, which is, let's say, an office address, or maybe a gym address, or maybe the health club address, or some other address. So while you have new address types being introduced, how do you go ahead and add these new address types as attributes in your employee class? It would involve you to go ahead and modify your employee class with every new address type that is getting introduced. That is where the IoC pattern comes in handy. The IoC pattern is what says that whenever an employee object has to be created, it in turn should be creating an address object. This is what is the default thing. Instead of the employee constructor creating the address object, let the address object be created and then passed on to the employee class. Right? So in this whole situation, what does IoC actually try to highlight you? Do not call us, we will call you. In other words, do not create the address object, we will supply the address object to you. And when we are trying to supply the address object to the employee class, address object is like a dependency object for the employee class. And this particular address object we are trying to supply to the employee class through the process of dependency injection. We are trying to inject the dependency object in the high-level classes. So now with IoC pattern implementation, what we are trying to highlight the point is, whenever a low-level class needs to be instantiated, rather than the high-level class taking the responsibility of instantiating the low-level class, which means in our example context, instead of the employee class taking the charge of creating instances of address class, there would be a mechanism in place which will create address objects and inject it into the employee class based on the requirements. And that is precisely what dependency injection is all about. So I'll just move on to the next slide, wherein we've talked about a file reader example. We talked about employee address, which is a composition relationship example. Similarly, we have a logging error example, wherein if you see, the logger application could be one class, and then you could have the log file to which the logging needs to be done. Your logger application class becomes like a high-level module, and the log file becomes the low-level module. Now the logger application class is required to create an instance of a specific type of log file depending on where the logging is required. Do you want to log the errors in event log? Do you want to log your errors in an application log? Do you want to log your errors in a text file, in a binary file, or do you want to send these error messages over mail? So there are multiple options that are available. And in all these things, how do we have, now the challenge that we have is, how do we get the high-level module, which is nothing but our logger application class, create instances of the low-level module classes. Now what are our low-level module classes? They are nothing but the dependency class, which are like event logs, error logs, sending mails, binary files, text files, so on and so forth. So we have high-level classes, we have low-level classes. Our objective is to inject instances of the low-level class into the high-level class modules. And this is what brings us to the dependency injection, where instances of the dependent classes are injected into the high-level class modules instead of the high-level modules directly trying to create them. So we move on to what is called the dependency injection.